Then the next, this table shows that the number of possible types in each system. For example, in cubic there are 3 different types. For example, in cubic, simple cubic, BCC, bodies in a cubic, and FCC, face in a cubic. Then the tetragonal, there are 2 types of tetragonal, and simple and body. Then orthorhombic, all 4 types are available: simple, body, face, and face system. Then monoclinic, triclinic, trigonal, hexagonal, trigonal, triclinic, and only simple level is available. The next diagram shows that the 14 possible types in 7 system. So in the cubic only 3, then the tetragonal 2, hexagonal 1, then orthorhombic 4, then rhombohedral, monoclinic, and triclinic. Finally, triclinic system shows the last diagram. So this is divided by 7 system. Then P equal to primitive and I equal to body centered cubic or body centered material. Then FCC, FC equal to base centered. Okay, in crystalline nature, crystalline materials, the first one is system, and then next important basic topics of crystalline nature. Then finally the characteristics of unit cell. So what are the important parameters in a unit cell in a crystal system? The first one is number of atoms per unit cell, number of atoms present per unit cell, as well as next coordination number, total number of nearest neighbor atoms, and then atomic radius. It is defined as half of the distance between any 2 nearest neighbor atoms. And then finally packing density or atomic packing factor. So atomic packing factor, it is known as total number of atoms packed. So volume occupied by the number of atoms divided by total volume of the unit cell. So small v divided by capital V. Okay, next we are studying about cubic structure. So we already know about cubic. There are 3 different types of cubic. The first one is simple cubic, then BCC, bodies in a cubic, then FCC, face in a cubic. So important lattice parameters in a simple cubic: number of atoms per unit cell equal to 1. That means each and every corner point is shared with 8 unit cell, so that 1 by 8 into total number of corner point per unit cell equal to 8. The finally 1 by 8 into 8 equal to 1. Then next, atomic radius of simple cubic, very simple, half of the distance between any 2 nearest atoms, so r plus r. Then 2r equal to a, r equal to a by 2. Then coordination number of simple cubic, nearest lattice points. Then the second diagram shows that the red color line shows that the number of nearest neighbor atoms, that is equal to 6. Then finally ABF value, volume occupied by the number of atoms divided by total volume of the unit cell. And finally the answer will be equal to 0.52. So finally the conclusion, it shows that 0.52 or 52% filled with atoms, the remaining 48 is vacant. That is simple cubic structure packing density. So finally important lattice parameters in simple cubic: number of atoms 1, atomic radius a by 2, coordination number of SC 6, then finally packing density 0.52. Then next, BCC, bodies in the cubic. So in bodies in the cubic system, as well as we are studying about the simple cubic system, that is corner points 1 by 8 into 8 equal to 1 plus 1 full BCC atom inside the unit cell. This atom only is added with 1 unit cell, so that 1 plus 1 equal to 2. Then atomic radius of BCC, that is a root 3 by 4. Then coordination number of BCC, the nearest lattice points neighbor atoms, that is BCC atoms starting with 8 corners, so that value equal to 8. Packing density or packing factor of BCC is equal to 0.68, so that 68% of the volume is occupied by the atoms, then remaining 32 is vacant. So these all are the important lattice parameters in BCC system, that is number of atoms 2, atomic radius a root 3 by 4, coordination number 8, then packing density or packing factors 0.68. The final and third parameter of cubic system, that is face in the cubic. So in face in the cubic, totally different from BCC and simple cubic. That means the number of atoms per unit cell equal to 4. So the first diagram shows that the corner atoms add with the 8 unit cells, so 1 by 8 into 8 equal to 1. Then next, face center atom, face atoms add with the 2 unit cell, so the value 1 by 2 into total number of atoms 6, the finally equal to 3. So finally the value 1 plus 3 equal to 4. Then atomic radius of FCC A root 2 by 4. Coordination number of BCC atom, the surrounding plan 4, then upper level and lower level 4 plus 4, finally value equal to 12. Then the next vacuum density of FCC is equal to 0.74. That means 74% of the volume is occupied by the atoms, then the remaining 26% is vacant. So these three are the important lattice parameters, possible types in cubic system. So in possible types in cubic, that is three types of possible. The first one is simple, then BCC and FCC.